must not be.
Well, welcome to today's session on Cloud Native Operations. My name is Colin Fallwell. I am Director of Observability with Sumo Logic. I deal with a lot of operational strategy and best practices and helping customers get value out of our platform around observability, and I got my good friend.
Hi, I'm Damon Edwards. I was one of the co-founders of Rundeck. Now I'm a part of PagerDuty. I'm the invited guest here, so I don't have swag to throw at you all, but if you come by the PagerDuty booth later, we'll throw some swag at your head.
Yeah.
If you'd so wish. Thank you for coming to our talk. I think this could have been called "You Build It, You Run It, But How," but we choose a more obtuse title. And really, we see this shift towards "You Build It, You Run It." We want to catalog what are some of the top ideas or the top things that we see high-performing organizations doing, and so that's what we put together today's talk about.
Today's topic, yeah.
Yeah, so where are we all trying to get to, right? I think. Oh, actually, it's not. There you go.
There it is.
Where are we trying to get to today, right? So I think if you think about, we're all trying to go after the same path. The first is sort of this cloud native word, whether you put it as a capital cloud native or just cloud native in the general concept. But we want this endlessly flexible, scalable, ephemeral, and resilient infrastructure and services. Mm-hmm. But it's not just the things themselves, right, Colin?
Mm-hmm. That's right. And to pair to that, right, from a development operations standpoint, we want this endlessly flexible, ephemeral, reliable, resilient delivery and operations. We want to have this capability to really observe and get that feedback loop really rigorous in the organization, and a lot of companies, and I'm sure a lot of you struggle with that today. How many SREs? SRE, 1, 2, a few SREs. All right, fantastic. Department level, any global, have to get around the arms of reliability for the entire enterprise? A few? Yeah.
For you folks who are SREs, just one quick show of hands. Put your hands back up for a second. How many of you have access to the source code for the applications that you support?
1,
some do,
2,
some don't.
3, 4.
That seems to be an interesting debate these days, right?
Yeah.
What constitutes?
How many don't? Sorry. SREs that don't. None. Okay. All right. Cool.
Flying bunch.
What's getting in the way? Take a look at these Death Star diagrams. From the top left, just a moderately sized modern retail application to Netflix to Amazon.com. There's a real challenge when I talk to a lot of my customers, a lot of my SREs that I do work with. When you're just in a department space or you move up and you start aligning to the business, you're trying to mitigate risk for the organization at the same time. You're trying to just understand all of this telemetry. There's this deluge of data that's just pouring out of these systems, the digital exhaust, logs, metrics, traces. What's really challenging through all of this is trying to understand what is reliability, what is normal, what are the unknown unknowns, and how do I observe that, and how do I get that in earlier in the life cycle. It's a real challenge when you come in after the fact, or you're trying to monitor, or you're looking across 10 different lines of business, any number of development teams, and you're trying to understand, or as a developer, you're trying to understand what does the business need out of the data that I'm curating out of my services and out of my systems. You compare that or contrast that to just the sheer volume of interconnected components now. You've got this explosion, this rapid rate of change, and then there's a broadening attack surface, especially with things like supply chain attacks that really, really challenge today's organizations to get around this idea of observability and being able to drive self-service operations. Never mind all the fact that all of us are carrying around these boxes of doorknobs, or I like to call them dork knobs, which is all that legacy stuff, and trying to do what's in the modern cloud as well as what you're trying to accomplish in legacy, and try to bring all of that along. Hard to get rid of it. And really the crux of it is that at the end of the day, you have, I think all of you could probably agree with this, a lot of different element managers, siloed tools, pinpoint tools that are limiting your understanding. How can you have an environment where you can have a common unified entity model around all of your data instead of all of these silos with different pinpoint tools that are vendor-supplied data. Some of it may be open source, but how do you get to a place where you're supplying telemetry to your vendors? That's one of the things that we're going to be talking about today.
So yeah, so Colin just talked about the complexity, in the true sense of the word complexity, and the scale of what we're trying to manage. But also think about what's getting in the way of how we want to manage things, right? That ephemeral, scalable, flexible, rapid way of operating things. So Werner Vogels took this idea of you build it, you run it, right? I think we've got to put his face up every time we talk about that, but it's not a new idea, right? This has been around in different iterations over the years. But what gets in the way, right? I think how we've used to operating, right? There's you build it, you run it, but everybody runs away, right? There's the no one's actually taking responsibility for the things that they're owning in production. Ownership becomes an obstacle, right? So how are we actually going to be able to to divide up these these services and decide who owns what? There's a lack of resources there, right? So just the idea of saying, well, a lot of organizations, they start down this path of you build it, you own it. They look at their teams and say, okay, well, at about 15 minutes into the meeting, we ran out of teams, right? Before we even got close to getting through the pile of the services that we own. And the last one being, there's these the traditional way of working through ticket queues, right? That we're trying to do the you build it, you run it, but we're basically siloed into our organization by functional areas, and everything needs to kind of flow through these slow-moving queues, and that really stagnates the information flow and makes it difficult to have any sense of real, true ownership.
Yeah. That really brings home the point. Like, how do you observe everything from the developer ecosystem, from the developer laptop, all the way through into production operations? And it's not just to collecting logs and telemetry based on all your lower environments, your staging environments, your UAT environments, your production environments. It's the entire CI/CD pipeline. It's doing software development optimization. It's looking at things like DORA metrics. It's really getting around and understanding there's no linear path to production. There's always dependencies that you hit bottlenecks, you stop, you've got to rely on another team, a shared services team, all of those ticket queues. How do you abstract all of that out? How do you take the human touch point from 12, 15, 20 touch points to get something to production down to zero? How do you observe? How do you monitor that? Two keys to overcoming these challenges. One, which we'll talk about today, which is observability-driven development. How many of you are doing ODD today, or observability-driven development, or have heard of it? A few? Most of you have not then, I would assume. So we'll talk about observability-driven development, which is this shift left motion into the development lifecycle around observability and self-service and autonomous operations through control plane.
And to be clear, there's lots of other things that go into the you build it, you run it model, but these are the two that we find as really being kind of the cornerstones for the organizations that get this right, or if going down that path towards these directions, tend to have a much easier time actually doing that distributed ownership, you build it, you run it, whatever term you want to use to describe this.
That's right. Observability-driven development is really about getting shared, consistent understanding in the organization about what things should look like, where you want to be, where you want to go, what's important to measure. And once you define what it is that you want to measure, what is even more important is how do you consistently apply that across the organization? How do you communicate that state? How do you actually capture the metrics? By what process do you capture that telemetry? What do you put into the logs? How do you curate that information so that you can get a high capability of process? CP is a term that's used a lot in the SRE space. If you're not familiar with it, it's a Six Sigma term, statistical model for really having a high control capability within the organization to understand what's going on. It's all about implementing your own observability. And what we see now is really this shift in the industry at large, going more towards open source, open standard, open telemetry, to really curate this information, logs, metrics, traces, all the event data coming in. So much of organizations today still rely on proprietary agents, and when you're doing that, you're beholden to opaque pricing. You're limited by what that tool does and what it can give you, what that platform can give you. It's hard to get that information out. It's hard to share it across the organization unless you pay a lot of per user pricing and other tricks of the trade. So observability-driven development is really the shift towards supply telemetry to your vendors. Own your telemetry pipelines. Build your own robust solution into your application. Share that. Build the standards, the practices. And it's not so much a technology thing, right? It's a culture and it's a process thing. We'll get into that. So let's talk about what is table stakes today, which is really test-driven development. ODD kind of follows this same model. You write tests, you evaluate, you refactor, and it's really between kind of a test and design function. Observability-driven development takes this broadly to the ends of the software development or product development lifecycle. You're defining the expected outcome, you're measuring the outcome, and then you're changing the features, and you continue to measure, and you continue to evolve, and you continue to improve and iterate upon what it is you think it should be. And if you're a developer, when you're doing observability-driven development, you've really got to start thinking about the hypothesis. What do I expect this to do? How do I expect this to behave? What code is being impacted? How often is it being hit? And what is the impact on X? And I say X because it could be anything. It could be impact on revenue, customer experience, omni-channel, customer attrition. Think along the value stream of the organization. Today, I think modern observability is really starting to align around this notion of value stream management, or VSM, understanding how am I getting flow of value to my customer? Where does the revenue line come back into the organization? And is everything performing and behaving as I would expect it to? It does a little bit more than just look at that production process. Observability-driven development really brings observability into the entire product development lifecycle. So you're looking at, how do I instrument the CI/CD pipeline? How do I understand my DORA metrics? How do I understand where my delays, my friction, my bottlenecks, where am I waiting for other teams? How do I reduce that down? How do I rearrange things? How do I continuously improve that process of getting things into production and then monitor what's coming back in? And at the same time, how do I really focus on what the business needs? My BI teams, my data science teams, my finance teams, the C-level, the C-suite. What kind of information do they need to be able to make effective decisions in terms of how do I go into other lines of business? And when you really, really nail down observability-driven development and you start applying that and you get that culture and that process in place, what you end up with is an organization that's more lean, that's more innovative, that can go into new lines of business. And we've seen that. We've got a couple of retail customers this year, the first year that they're able to not go into a lockdown during Black Friday and they're continuing. They're continuing to push software. They're continuing to release because their confidence level is high enough, because they have the right level of observability really driving what it is that they're trying to accomplish. So if you're a developer, or you're in site reliability, or you wanted to really start to cultivate that culture, one of the things that observability-driven development really impresses upon is, as a developer or as somebody in IT that is responsible for doing observability-driven development, shifting this left, knowing how your systems operate should be declared by the developer. Now, there are a lot of open source capabilities and tools that are out there now. One of them is OpenSLO. It's on GitHub. You can find it. It's a process. There's a CLI that you can run. You can put all the parameters in. You can basically define SLIs and SLOs by objective, and you can codify that and put that into Terraform. I encourage you, if you haven't found it, go check that out. But what is normal? How do you articulate reliability to the organization? How do you say that this service or these services, where does it fit into the value stream? What does the value stream need? Law of nines. If something doesn't need to be 99.9999% up, don't try to achieve that. Figure out where you need to balance uptime and reliability to cost in the organization, cost to the business to achieve really high reliability. In some situations, it's not necessary, especially if you're multi-cloud and you're getting into different paradigms in terms of deployment strategy, if you're testing in production, those sorts of things. Release gates, having robust controls, a control plane to be able to manage what goes out and what doesn't. When you drop below an error budget, for example, do you stop change going into the production environment? Do you go into a period of normalization where you are not innovating as fast as an organization and you're stepping back and taking a look at where's the change need to happen? Is it infrastructure? Is it systems? Is it in our source code as far as infrastructure as code? What do we need to fix in order to go fast again? And being able to articulate that and have agreement across the organization, that's really, really, really key. So let's talk about culture. From a culture perspective, every engineer really must care about their application status. You can't just be an engineer anymore that just writes code. You have to own it. If you're going to own it all the way. And you've got to care about the needs of the business. If you're a developer and you're relying on somebody else to interface with your BI teams, your C levels, you need to go and start having those conversations. I encourage developers all the time, go take your CIO to lunch. Figure out what he needs. Understand the needs of the business, where the business is going, be able to articulate that, understand that very well, and then step back and think about what is it that I need to observe in my systems to be able to support the hypothesis and where I want to go in terms of building reliable applications. Every engineer must do on-call rotations. You can't get around the problems if you're not addressing and dealing with those problems. You know that there's going to be a certain amount of overhead in the team. Somebody's on call every week. Rotate. Make sure that you're on and doing that. You should have, at this point, a dedicated team that is building the shared services or this capability to be able to build the guardrails, the foundation, the framework for doing observability as code, to be able to put SLIs and SLOs into practice, to have a normal standardized process by which to do that, so that you're shipping software to production in something that's consistent across the organization that isn't done 10 different ways across 10 different lines of business. Build observability into every tool chain. Cannot express how important that is. And that includes CI/CD. And the beautiful thing about OpenTelemetry, and we'll talk about this a little bit here in a few, it's not just a tool for instrumenting and doing auto instrumentation in Java like kind of the classic APM. You can literally monitor any life cycle. You can trace any life cycle. You can do it in your CI/CD pipeline. You can build your own SDKs. It's very flexible. We've got a lot of customers that do a lot of really unique things that you won't find out on GitHub in any repo. They've just taken it, they've forked it, and they've completely transformed what they can do with it. And they're doing things that nobody ever thought you could do with OpenTelemetry. So let's talk about process. How many of you still spend a good chunk of time in staging, in your staging environments? Stop testing and staging. It's not production data. It's not valuable in staging. You're not touching the customer. You're not able to get that instant feedback. Why are you still in staging? Because you lack that visibility into what's going on in production. So when you're in production and you're testing code in production, you're able to really accelerate in the feedback and touch customers either through canary deployments or ring deployments or going multi-region, doing chaos engineering, observability-driven development. Organizations that are doing that, you can come down to our booth. We'll have Alaska Airlines that are going to be talking about some of the things that they do around chaos engineering. You can pick up one of the sheets. I'm not sure on the time right now. Shadow testing, going out, talking to customers. Hey, take a look at this feature. Tell me what you think. It's half-baked. It may not work, but I just want your ideas on it. But when you put your code into production and you spend less time putting that code into staging, you're going to accelerate what you need to understand about modern observability, getting that observability into the organization, back into the development teams, and you're going to innovate quicker. So those are all kind of the good things, but I always like to kind of draw out the anti-patterns, because if you fall into these anti-patterns, then you're not really set up for observability-driven development. So if you have a lot of different haystacks of data, let's say you got different development teams and everybody's using their favorite tool. If it's a vendor-sourced data, you're beholden to a vendor to supply you telemetry, you're limited. If you've got a lot of different UIs and consoles, a lot of different glasses of pane instead of a single pane of glass. Or you like a unified analytics and control plane for self-service automation, something that is robust and universal that everybody can leverage, then you're not setting yourself up for observability-driven development. And I would bet, if we had a raise of hands, I won't ask you to do it because your hands are probably tired, but the vast majority of you fit into one or more of these categories today. Solo thought exercise I like to do. We were talking about Death Stars earlier. Let's take the Death Star from Star Wars. It's a really large, complex system. If you had that Death Star put together and you had, let's just say, 20, 30 different lines of business that were responsible for building that, and every one of them maybe used some shared tools, maybe had Datadog, New Relic, had some open source, had some Grafana, had some Prometheus, just, hey, whatever you want to use out there. None of those tools really interoperate and talk very well together. And I would argue that Alderaan would still be around because the Death Star never would have been successful unless they had a unified analytics platform. Now you think about that, right? When you get into modern enterprise business where you're looking at really large systems, very complex, connected systems, so much engineering time, and I've talked to so many customers about this, the number one pain point is how do I consolidate? How do I consolidate? How do I consolidate tools? Because I can't get a consistent view across everything in the environment. This is especially true for the SREs that are trying to mitigate and manage risk in the organization. And the challenge is that every one of them is its own element manager. It may only have metrics, or it may only have traces, or it may only have logs. It's not looking at everything. It's not able to bring together all the different telemetry sources into a common analytics model. And what do you need for robust machine learning? Machine learning is not a vertical scale thing. It's a horizontal emergent property. Like you've got to have horizontal entities that can create a lot of correlations between them. So ML runs best in a horizontal system where you can have a lot of correlation between entities in high cardinality. So if you're looking for a vendor, you're looking at your tools, and you want to evaluate your tools, think about how well does my tool support infinite scale, horizontal scale, and how much can I do machine learning across everything in a unified way where I can maintain a lot of outlier detection and correlation across all of that cardinality of data, the tags, et cetera, across metrics, across logs, across traces. Because when you get to that place, and when you're owning your own telemetry, and you're bringing all of that information into a platform, one, if you're a Sumo customer, you already know, but two, if you're not, and you choose, hey, I don't want to use Sumo, I want to go somewhere else, you own the telemetry. You don't have to rip anything out and replace it. You own the telemetry, it's baked in from the developer ecosystem all the way through to production. It's consistent. And it's declarative because you put it in as code. All right. So if you want to observe from the laptop to production, consider OpenTelemetry. If you haven't really started messing around with it, I encourage you to go out and start playing with it. It's not APM. It's cloud native, it's open, it's interoperable, it's extensible. You can do a lot of things with it. It's an open standard. CNCF just recently put it into, I think, incubation status, so it's gaining a lot of traction. There's a lot of contribution going into this initiative. And I remember 3 or 4 years ago when the bulk of the work that would come into the OpenTelemetry project was in the summer, and it was just really go put the interns on it. And Amazon and Google and Netflix and others would just put their summer interns on these projects, and you'd get a lot of movement in the summer months, and then it would kind of die off and things wouldn't really go anywhere. Now we see that really starting to shift and trend to where there's just a lot of advancement and maturity coming along. And you can trace any life cycle with it. It's not just for languages. And you'll forever own your telemetry. And if you're not really familiar with what it is, it's from a distributed tracing standpoint. You have frameworks, you have a collector. You don't have to have a collector, but you do have a collector, and it's a Swiss Army knife, and you've got a very lightweight SDK. There's different flavors of that SDK. You can build your own SDK that exposes a common API, and then you can trace any framework. You can put any kind of content, business transaction data out of your application into that. It does a really nice job because it does all the correlation for you. So all of the logs that get emitted in sequence from all of these calls are decorated with the same span ID, trace ID. So it makes it really easy to understand out of these 3,000 log entries that were on that one transaction, how do I look at that in time sequence? The collector is really cool because it's kind of like a Swiss Army knife. You can take Thrift, you can take the older Open Census protocol, you can take Open Telemetry, the OTLP format, you can bring in Prometheus, which is still a little shaky. It's still somewhat experimental, but you can bring all of that data in, you can transform it, and you can weave everything together into a consistent stream where everything is correlated. Tracing, metrics, log, it's all interwoven together into a continuous data stream of OTLP. All right, if you haven't, I recommend these books. These are really, 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 really good books to get your hands on, to understand the topics and really delve in deep to the recipe of observability-driven development. Observability engineering, I think, is somewhat available. It's a brand new book that Charity Majors with Honeycomb has just put out. But get these books, read them, digest them, great content, great information. And if you would like to know more, 5:15 at the Sumo booth, I'll be talking about the future of open telemetry at Sumo Logic. So I'll be going into our roadmap, talking about where we are in our OT distro and the different phases of the beta. And at 5:45, I believe, we're going to be at Rundeck. Yep. Talking at Rundeck. But first, now I'm going to turn it over to Damon. Damon, go for it.
Yeah. It's funny, when Colin and I started this talk, we decided we weren't going to do the half and half talk, and then here we are, half and half talk. So.
Half and half talk.
I hope you're all still with us. So what Colin's been talking about is the view, right? What I want to talk about now is the do, right? So if you're going to empower somebody to take action, we're going to empower people to own the full life cycle of what they're creating. Part of it's the view, right? How do we empower them with the right information to make the right decisions at the right time? But that's useless if we don't give them the do, right? The ability to actually go and take action. So that's where the other half of this, is self-service and autonomous operations, comes in. So first of all, let's think about what life is like in operations, right? And like now, in the modern world, everybody spends some of their life in operations. It's rare that we can completely avoid it altogether. But it's sort of split 50-50, right? You kind of half your time is spent where someone's interrupting you, right? You know something, someone's coming to you for a question or to do something but some kind of interruption is coming your way. And then finally, when you get that cleared off your plate, right? Then you end up interrupting somebody else, right? You're opening a ticket for somebody else to do something or waiting for somebody on Slack to come around for you, right? So it's a lot of getting interrupted and a lot of then waiting around for folks. That's sort of life in operations as it's always been, right? And then, operations still depends a lot on these few experts, right? You go and ask people in organizations like, hey, how do you diagnose a problem in this particular service and restore it, right? Or, how do you provision this, the next version of this new load test environment, right? Or, hey, is there a performance issue or something going wrong with this service, or is it just me? At the end of the day, it always comes down to there's like somebody, right? That's like Bonnie. Bonnie does it, right? And why is it that Bonnie always has to do it, right? Well, she's the only one that knows what's the current state of things, right? She knows what's the right sequence of things. She knows what's the right version of this script or that binary that I need to go and grab, right? So over and over again, we find ourselves having to rely on these different kind of silos of knowledge. And in today's kind of a complex world that Colin was describing, this is getting on its own more and more difficult, right? Bonnie's life is becoming more and more hard to be that fountain of truth. But underneath it all, it's really what we call this automation gap that is really making Bonnie's life miserable, right? And let me describe what we mean by this automation gap. we see inside a lot of organizations, there's been a lot of investment in what we call like task-specific automation, right? I've got all the scripts, I've got all the tools, I can move the bits from point A to point B, I can generate configurations, I can hit APIs. Whatever it needs to be, the little elemental pieces are starting to get more and more automated, right? But this curious thing happens where if you talk to people with the hands on the keyboard, like, hey, do you have a lot of automation? They're like, oh, we got piles of it, right? We got everything from shell scripts to Python scripts. I got Ansible, I still have Puppet and Chef, and I've got even some CF Engine way over there, right? So we've got plenty of task-specific automation. But you go and ask, people 2 or 3 degrees away from the keyboard, hey, how automated are things in your organization? They'll be like, oh, not at all, right? It's just constantly tickets going here, going there. Things still, take too long to get done. It's because there's this gap between this stuff that I've got on the right that the experts like Bonnie know how to call and how to use. And I got all the people on the left that could use this, right? But for some reason, they can't, right? And generally, these reasons kind of fall into one of these 3 gaps, right? First is like a knowledge gap, right? Like, hey, I could do that, or I sort of know how to do that, but I'm not sure of the current state. I'm not sure if that's the right version. I'm not sure, was it -I or -E, or what did the firewall people say I should or shouldn't do? So generally, we end up, escalating off to somebody else, right? Another gap is a skills gap, right? Maybe, hey, these folks don't know anything about the network, or these level 1, support folks don't know anything about, the various architecture pieces of the application. The idea of saying, hey, here's an SSH key and some pseudo privileges and a script and say a prayer and, don't blow anything up, it's not going to happen, right? Which brings us also to the 3rd gap, which is the access gap, right? Whether it be for security and compliance reasons, right? Like, thou dirty people over here shall not touch this clean, pristine thing over here. Or it's the management idea, like, oh, you're going to blow things up, I can't let you in here, right? So it's one of these 3, gaps, right? Forms this automation gap where all this investment over on the, looking here on the right, can't be leveraged by all the folks on the left. So therefore, we keep making these investments, but things aren't really getting better. Maybe the subject matter experts are 10% faster, 15% faster, but still it's a lot of tickets, a lot of waiting, a lot of that interruptions that we had before. So where does this automation gap bite you, right? Where does it hurt you every day? If you think about operations life, right? One of it is you're responding to incidents. Maybe the smaller sliver, but it's the more exciting. We'll use that euphemism side of things where I'm being I worked on my telemetry. I've worked on my, got my PagerDuty all configured. So now I've got the right information being routed to the right people. But what can they do, right? They're still back to that automation gap where they have to probably, either dumpster dive through some wikis and SharePoints, or they probably have to escalate off to somebody else. But we get these, longer incidents and a lot of frequent escalations, which is really the painful part, right? We're constantly interrupting folks in the organization. The other part where the automation gap hurts you is on what we call the service request side, right? Just basically all the peacetime work, all the project work that we constantly have to go and interrupt some subject matter expert to do something for us, right? Hey, can you expand this capacity, or can you reload this environment, or can you change this configuration, or asking questions, why something this way? And each of those requests ends up being a little bit of waiting, right? It's injected on the person who has to make the request, and there's some interruption being pushed onto the subject matter expert, right? So now we have slow turnaround times and frequent interruptions throughout the organization.
Yeah, and it's a great point here. So one of the things I mentioned earlier, just quiz, anybody can figure this out. What do you think out of observability-driven development, some of the things that you can do with that help here? Where your time's going, understanding, having visibility to where things are going. I would say one of the best cures for this is chaos engineering. Being able to engineer chaos into your environment, to come up with a hypothesis, sit down as a team and say, what do you think would happen if we flushed Memcache? Or if Redis went down, or if this went down, or that happened, or this happened. And everybody come around and think about, well, I think this would happen, I think this would happen, I think this would happen. Okay, let's go test that. And let's do it in a way where we've got the capability to continue operation in the process, structure everything, what do we need to quickly be able to recover, and those sorts of things. But now your incidents and your service requests start to fall dramatically because you're starting to engineer chaos into your environment and you understand where the weak links are. You discover things you didn't know would happen. And one of the really cool things is now you really get to deterministic state with what are you monitoring and how are you monitoring it. And what do I do when I see this again in the future? And now that leads to automation.
Yeah. And, that's an important part, which is we'll talk about in a minute, which is cutting down on what hits people. But when it does fall through, the work does flow through to folks, how do you close that automation gap, right? It's really about self-service. How do you enable anyone to safely do what previously only your subject matter experts could do, right? So I can, the first step is the humans. I'm empowering the humans. The next step is obviously to trigger these things, automatically, which we'll talk about. And by doing that, on the incident response side, now we're pushing control closest to the people that are going to be, at the coalface, so to speak, of the problem. By doing that, even just diagnostics, putting expert diagnostic. What would I do if I had to escalate up to these, put out the big call to everybody on call for this service because of some problem? The 3 or 4 people have to show up. What are the things, the first 5, 10 things they would do to play the it wasn't me game, right? Like everybody logs in and says, hey, it wasn't me. What if the person responding could run that themselves? Network. Yeah, could run that. It's always DNS, right? Just skip to those folks. But how can we push that closest to the problem so we can actually run that either the first person that logs in can run it and everybody can see what happened, or run it before they even log in. Shorter incidents, fewer escalations. On the service request side, it's really just about enabling self-service. How do you take those top, 10, 20, repetitive actions that happen time and time again across each team, turn them into safe self-service, let people serve themselves. It's faster turnaround time because it's instantaneous, right? You're going from a request to a self-service, and fewer interruptions. And some interesting things, start to happen at the organizational level. The first one is the ability to eliminate the queues wherever you can. And if you think about it, everybody likes to work in their organization. You're working in your context, in your team, with your tooling, with your process. But nothing lives in isolation in the organizations that we work in, or just in general, right? So what happens is we came up with this idea of saying, hey, let's put a ticket queue in there, right? There's this mismatch between request, mismatch between tooling, mismatch between process. So we're going to put a ticket request queue in there. Anytime I need to go outside of my team, I'm going to put it in this queue, and I'm going to go somewhere about it. And the reality is, if you think about it, in other fields and other kind of high consequence domains, they really study the idea of queues and working through queues and how expensive it actually is. I almost said toxic, which is part of it, but just look at it purely as a cost matter. Queues cause longer cycle time, increased risk, right? Because that lengthening cycle time, more variability, right? And not the good kind. More overhead. We got to manage all these queues. Lower quality, right? And the interesting one is less motivation. And they found out that people have to work through queues. They aren't able to complete the work on their own. They aren't able to see the results of what they do. Are intrinsically less motivated, right? It actually kind of brings the energy down of the organization. And these expensive queues tend to, appear in any organizational model, right? We see folks that go towards these heavy kind of cross-functional teams, right? Or the folks that are sticking to more of the, we're going to have distinct development teams, distinct kind of operations organizations. And we find out these queues pop up all over the place, right? So we're injecting this cost, everywhere we go by not enabling people to serve themselves, right? And another so by going the self-service route, we're reducing those queues. Another interesting impact we see is being able to reduce toil, right? So I'm sure folks have heard the concept of toil. I think it's probably the most innovative part, or the most kind of one of the what should we call it? Like one of the most important innovations that came out of the SRE movement is putting a name on this idea of toil, right? Toil being that repetitive, rote, scales with the volume of your service. More users, more volume, more service, more toil. It's a stuff that could be and should be automated, but we don't. We're not adding enduring value, right? Maybe we have to do it day in, day out to keep the business running, right? It's like a necessary waste, but fundamentally we're not moving the business forward, right? Versus engineering work, which is the work that we're doing that's moving the business forward. It requires human ingenuity, and it's actually something that we're using to improve, adding that enduring value. And the important point here is, in the operations world, having enough capacity for that engineering work, you can use it for two purposes. One is to reduce toil, and the other is to improve the business. And if you run out of that engineering capacity, if you get overrun by toil, you basically hit this bankruptcy, right? Where you don't have enough engineering capacity to reduce the toil, let alone move the business forward, right? And you're constantly in this, wheel spinning motion, and this is really this kind of inevitable downward spiral. So another kind of big case for a self-service is being able to encourage organizations to keep that repetitive work off of them. If things that are happening time and time again, how do we create it in a safe self-service manner that we can hand off to other folks? That keeps those requests off you. So instead of dying by a thousand tickets or 1,000 cuts, we're actually starting to gain back that time by all of those tickets that were either pushing off us completely or just they disappear into the background because the self-service is doing its peak.
Yeah, and it's not just in support and operations, it's in Jira. It's in your development teams. Jira has a lot of queues. If you follow and track and look at the dependencies across teams, you're going to find those queues are everywhere. And those are the most important ones to go and resolve.
Yeah.
How do you streamline that? How do you cut that out?
That's actually a great point. I mean, we see this a lot too in organizations. They think about the big incidents, or they think about the big projects. And say, well, that's what we got to go and look at. But it turns out it's all the day-to-day sort of operational small requests that they never knew were happening until they analyzed kind of the flow of work. And also it was the P3 and P4 incidents. The stuff that people thought, oh, well, we're just sort of handling that in due time. And then people started to log into bridge calls and looking at them, and there's 20, 30 people around a P2 or P3 incident, and they realize how all this time goes to. It's like a hidden illness in the organization.
Yeah.
So when thinking about this automation, there's kind of two ways that that it helps us. I think people think, well, hey, automation, what's it there for? Right? It's there to replace the humans, right? And the reality is we at least from the PagerDuty perspective, see it as automation is there to support the humans. If you look across all the different high consequence domains, operating rooms, air traffic controller, nuclear power plants, big mining operations where people can lose life or limb, they find out that automation to replace the humans, they haven't been able to figure out billions of dollars, thousands and maybe millions of person years trying to get the humans out of those situations. Just causes more problems, bigger problems, right? Instead, they say, hey, the automation is there to support the human, right? So kind of look at it as there's sort of two modes when you're thinking about automating. One is called like the Iron Man mode, right? How do we take our normal responders or the normal people who fill requests and turn them into superhumans, right? How do we give them the tooling around them so they can do what previously only the experts could do? They can respond better, faster, cheaper, safer, distribute the workload more evenly. But then the other side of this is how do we build the robots to protect those humans, right? To say, hey, this self-service that we can keep away from them, right? The event-driven, incident, diagnostics, even incident remediation, auto scaling, automated event-driven provisioning. How do we basically move things forward so we're able to, keep as many of those things off of the humans, reduces the toil level, and lets us move forward.
And with observability-driven development, this is key, right? Because that capability can be integrated into the service. Now your service has the capability to communicate directly and explain, this is the state that I'm in, this is what I need to do. Do I need to employ circuit breaker? Do I need to shift and go into a, hey, customer, I'm going to change the UI dynamically to say I'm busy right now? Do you limit what you can do in real time and go asynchronous in a workflow or a workload because something downstream is not reliable, so you're going to queue that work and put it to the customer directly and then recover and notify? Like, those are the kind of things in terms of how do I take customer experience into all of this with automation, building that control plane, not just the humans inside of the organization, but extending that to the customer as well.
So, we kind of see this pattern developing across organizations that are going down this automation path, trying to close that automation gap. It sort of goes left to right. There's some phases. I don't want to call it a maturity model, but you can look at that if if you'd like. But the first is really the kind of in that manual mode, right? Where, and I should say, this is a good point to say that people often think about this journey to their automation competency or maturity as an organizational-wide thing. Like everybody has to be in the same place. But we find that most organizations kind of work by business line or by particular system they're working on, and it's sort of an evolution as you as you go, right? And so the first one is manual, right? Things are kind of documented procedures. We're still heavily dependent on tickets. Almost everything needs an escalation. But at that point, it's just about getting started, right? It's about letting people find the tools that will work for them, not overly standardizing or optimizing to start, but starting down that path of automation. The second is after that point, we've built these islands of automation, right? We've got all that task-specific automation that we were talking about. And at this point, it's about two things: about standardizing, right? How do we say, hey, let's have make every procedure our best procedure, right? How do we, even amongst teams, collaborate and say, this is how we're going to diagnose things, this is how we're going to resolve these problems, this is how we're going to fulfill these requests. So we start to build these standard checklists, these standard automated sets of procedures. And then the other part is, now I think what's interesting about this part is it's still in that reactive mode where we still need the tickets, right? We're still routing the requests from expert to expert. So the experts might be more productive, but the organization may not have started to see, kind of the big benefits yet. And at that point, what people are really interested in is turning on that self-service, right? How do we start to delegate that automation to other folks so they can run it? The automation is, kind of more broadly available self-service, and this is where we see, kind of from an organizational perspective, new organizational models start to emerge, start to be able to work in a more distributed and decentralized way. And then I think what a lot of organizations want to get to, which is starting to emerge now, and why we start to collaborate with Colin, is around the proactive side, right? How do we move to the event-driven? So once we've got our procedures where we're moving from it's documented to it's automated for certain people to it's automated for everybody, to how do we get the everybody out of there? How do we start to make things more event-driven as we go? And it's not going to be everything, right? It's sort of an 80-20 rule. So we can try things. The robots can try to keep problems away from humans, try to keep requests away from humans before the human has to be called into the.
There is a really interesting link between any one of these kind of like 4-stage models and the journey that data takes. If you think about it, on the left, you got a lot of data. You process that data, it becomes information. You put that information in context to what's going on in the environment. Now you have knowledge. You accumulate knowledge over a period of time, and you really catalog that knowledge, and it becomes wisdom in the organization. And that is, as an SRE, my background is performance engineering, site reliability engineering. It's all about understanding data and trying to derive information from it, processing that, being able to, analyze the outliers, understand relationships, and then operate around chaos engineering and performance engineering to understand the what ifs, what is the best case, what is the worst case. And that is the foundation to everything that you're going to do in an organization in terms of process change, in terms of organizational change, in terms of organizational maturity, and automation. Because automation, to have robust, mature, like kind of wide scope automation, wide scope AI ops, it's all about having strong understanding about the data and the relationship of that data to the environment, to the customer, to everything that you're doing in the organization. So that reduction in toil, and you have to go after understanding and knowledge. What does this information mean? What does this data mean? At just the data layer, right? Just the raw machine scale data. Nobody can understand that. It's too much. It's too much data. So you've got to reduce it down and distill it into something that's meaningful that everybody can understand and agree on. That's what wisdom is. Just had to throw that in.
Yeah, no, and if you want to talk deeper about sort of how organizations go through this, we could talk about how people use Rundeck, to help them through this automation gap, how the observability layer gets modeled in. As Colin said, we'll be in our respective, we'll do a little booth crawl later this evening for both of our booths. You can come by and talk, and we can show you some actual details and give you demos and all that
all that good stuff.
Yeah. So, Colin, give me a recap.
So ODD, observability-driven development. It's the same thing as test-driven development. It just extends, right? Trace everything. Look at how can I implement the life cycle across the entire organization, understand that. Map the value stream of the organization, understand the flow of value. It's not just about revenue into the organization, it's how do you get value to the customer? What does that look like? How do you measure that? And then take action on it and build your features and the capabilities around that and build the hypothesis on how can I deliver better value to my customer. The revenue comes as a result of that. Own your data. I cannot stress how important this is when we start getting into cloud-native operations and we get out of hybrid and on-premise data centers and we go into the cloud. It is imperative as you scale and grow, especially as you get into multi-cloud. You don't want to have to rip and replace. You want to be able to build the best in breed, the best-in-class observability solution around your own telemetry, your own data. If you own it and you bake it into the foundation of everything that you develop and write and put into production, guess what? You have the innovation potential to do continuous improvement and innovation throughout the life cycles, iteratively, on your environment. And that is what builds the most robust feedback loops. And I can tell you, hands down, the companies that are the most innovative that I work with, that are the most successful that I work with, this is what they do. They own their telemetry. They don't. They're trying to weed everything else out. They're trying to bake everything in and build it into the fabric of what they do, the essence of what they do. And then, so that really comes down to the culture. Focus on the culture and focus on the process. What does it take to get there as an organization? That is, so many people think, well, observability, it's a technology thing. No, it's a people and process. Because it's about data, it's about understanding, it's about knowledge, and it's about developing wisdom in the organization and sharing that success. Find the organizations that's doing it the best, figure out what they're doing, and then start to spread that out. Bring people together, share the success.
So that's the top line's the view. So remember in the do, what do we got to focus on, right? Number one, closing that automation gap, right? That is huge. We want to get the value out of all this work we've been putting into this, component or task-specific automation, closing that gap. What do we get out of that? Number one, eliminating queues, right? Huge organizational drag come from working through ticket queues. It's become sort of the default way that we do everything. It's not a high-flow, high-velocity way of working. It never will be, right? It's not right for all kinds of work, but if we want that high-velocity, high-flow work, we need to focus on eliminating and reducing queues. Which also is eliminating toil, right? That self-service gives us the ability to, or implementing self-service gives the ability to keep that toil off of folks, and through other means as well, they can reduce that toil. And then, finally, kind of think about those two modes, right? How much of this is self-service, right? If I'm building the automation to augment the humans, right? The responders or the request fulfillers, whatever mode they're working in, enabling anybody to do what previously only your subject matter experts could do and do it reliably and do it safely, or also the event-driven, right? Which is the robots that keep the problems, keep the requests away from the humans, and both these things need to work in balance, right? And it's it's never like hey, we did it once for the organization, we're done. I think you'll see per service or per business line or per thing you're rolling out, we kind of always start in that sort of manual world, and we get more and more mature down that path of the reactive and the responsive, and then towards the event-driven proactive, while other parts of our organization might be all the way back at the manual, right? So it's it's an evolution that constantly moves, and we have to keep balancing these things in our heads. So I think that's it for today. Come by our booths. I think we're going to start at the Sumo Logic booth at
5:15. So if y'all want to, anybody's interested in taking a look at what we're doing with OpenTelemetry and really kind of our next gen in terms of all things collection around both operations as well as security, come check us out. We're, I think, 989, 969, something like that. We're at the back in the expo. You'll find us. Big sign, says Sumo. Come join us at 5:15, 5:45. We'll be in the Rundeck booth, PagerDuty booth.
The PagerDuty booth.
PagerDuty booth.
I've not seen it yet. It says PagerDuty on it.
It's pretty. It looks nice.
You'll find it. And then, we'll be talking about Rundeck and do some demos and things like that, and we can talk.
If you didn't get swag, I have a whole box up here. So feel free to come up, grab some swag. We've got some information here on our full stack application observability, real user monitoring, all that kind of stuff. You want to check that out. There's also some in the back. We really, really, really appreciate everybody coming out and spending time with us today. Thank you very much.